Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about follow and secure the bit with Intel, with special guests Greg Clifton and Steve Orrin. Greg, welcome to the show. Everyone, if you don't remember Greg, he was my second guest on the show. Greg Clifton is our director of DOD and Intelligence, right? We need some intelligence.
That's right, Dan. We got to have a little bit. Yeah, thanks. I was trying to remember if I was your first or second, so thanks.
You were number two. Now, I also have a regular on the show. In fact, maybe it should be Steve's show anyway. That's Steve Orrin, our CTO of Intel Federal. Welcome back again, Steve.
Thank you. Happy to be back here again.
All right, today we have a really interesting topic. It's actually a revisit to our second podcast, which was Follow the Bit, but we also want to secure that bit too. So that's why we brought Steve on. He's our security expert. So let's start with Clifton. You've got a great story around Follow the Bit. Tell us about it.
Yeah, this all came about because we were trying to help make sense of this super complex edge to cloud environment, and certainly in a Department of Defense environment, what was going on at the platform level with ships and ground vehicles and everything else that you would put on the edge, from individuals to things in the air, right? And then how do you collect the data? How do you analyze the data? How does it move along the path, whether it stays at the edge or it goes back to a theater operations center, goes to a ground processing system, or goes all the way back to an analyst? So it was all about this moving data and kind of figuring, well, that's just zeros and ones. It's just bits of data. And it's all about how do we help shorten that cycle time of processing, analyzing, moving the data across this chain to get to mission effectiveness, decisions, actions, all across this piece. So that's where we came up with this Follow the Bit. And where Intel comes into play here is how do we help, as I talked about, shorten those cycles, or where's there a bottleneck? How can we help our customer set, our partners, get rid of those bottlenecks in that data flow with our portfolio of technology? And I think we talked about it in podcasts, and Steve probably has. It's all about matching technology to mission, and where can we bring this technology to bear in this data flow and in this architecture.
So go ahead, Steve.
I was going to say, and one of the things, especially the more recent trends we're seeing in that end-to-end architecture, is in the past where it was all about moving the data from the edge back and trying to make that as efficient and as fast as possible to get results. The trend now is really about moving the compute and the processing and the intelligence forward to meet where the data is or where the data is going to end up. And so it's not just about how do we move the data fast, but how do we process the data where it is and get the intelligence in the area that is needed in the context of in theater or in the domain, and be able to provide the best capabilities to get you those real-time and near real-time responses, and be able to give you the intelligence you need when you need it, and not have to wait for someone on the back end to give you an answer.
Yeah, and Steve, even JADC2 is a great example of that, right? And I've taken this map and this slide that you see here, and I've talked to a number of folks from the DOD, and they're like, yes, that's JADC2, right? How do we boil this complex thing down into ones and zeros and moving them around?
So you guys brought up, very complex ecosystem. So what are the main challenges? Steve, you mentioned moving applications to the edge, moving data back to the data center. Those are two different operational models. Which one do I use? Why do you? What problems do you guys think we're going to run into when we actually try and make this thing real to realize it?
Well, I think there are multiple angles you have to look at. Some of it is the foundational infrastructure. How do you provide the right computing, storage, memory capabilities to drive analytics at the edge, to drive the processing at the places you need it? But there's also an angle about how do you manage those applications, manage the data? How do you introduce quality and curation of data further up the food chain? And then a foundational piece that I think we're going to talk about in more detail is how do you secure that data throughout its life cycle, from its data generation all the way through analytics and back again, and protect it in these multiple domain environments, not just where you have all the security protections of your classic cloud or data center. But now you need to be able to protect this important data all the way out at the edge.
Yeah, that's Steve always bringing up security. We can count on Steve for the security part of things. And we will talk about it. Thank you, Steve. But I mean, Clifton, what do you think about, I mean, when we started tackling some of these problems, I ran into really long development cycles to deploy applications in this ecosystem. And we found some common things. One is they're hard coding software to hardware, specific hardware, right? Because, hey, only this specific hardware can do that type of mission. Are we seeing a change there? What's coming up with that?
I think yes and no. I think where we need to get to as an industry on this is where, if you look at this complex environment, you get to more that heterogeneous compute where you've got lots of different engines at different parts of this chain, whether it's CPUs, GPUs, accelerators, FPGAs, sort of you name it, but that the underlying software can run on that hardware. So you can't get locked into just a certain software stack or code stack, which is part of the beauty of what Intel's done for years, right? Is that portability of software, that open framework, open system, x86 and others underlying. I think the other thing, Darren, that always hits me that's super important when you start looking at how do we develop capabilities here, the government is always about modernization. And I think we have gotten to this mode of modernization is, well, let's just put this in the cloud from an infrastructure perspective. And that's all fine. But what we really have to do is understand the workload, the data flow, why I need data to go from here to there and at what speed and what is it doing. It's not about how I buy IT, right? Is it in a cloud? Is it on-prem? Do I pay with O&M dollars or procurement? It's what is the data really doing? And then optimize the flow, the architecture to take advantage of that.
So that sounds really complex. So I mean, because every capability I deploy in mission is going to have different parameters, right? So how do I manage? That sounds like it's complex, and my deployment times are still going to be really long. Are there any tips or tricks? Are there anything that Intel can help bring to the table to decrease that deployment time and to get things out the door?
I'm going to turn that back around to you because you've been working on the DevOps environment and some really interesting things in the work you've been doing.
So yeah, I think you hit it. I mean, DevOps is really, and we're seeing a huge increase in importance of DevOps across all the DoD, right? Every department in DoD has a DevOps practice, trying to come up with common platforms. I think one of the key things with that is the concept of that write once, run anywhere concept that you were mentioning with the x86 chipset, and also with Intel's One API, that open source set of libraries, so that I can write a complex analytics or AI job that can run on a GPU, a CPU, even an FPGA with the same code base, so that I can actually test these complex systems that have lots of interactions between lots of different microservices. I can test that in my data center and deploy it out into the field, and it will behave the same. And that is a huge uptick. I mean, something that will make it faster to deploy applications.
So Darren, yeah, if you think about it, this is really about how the rubber meets the road. If you think about how those applications are being developed, in containers and in other sort of containerized style DevOps environments, and then having the underlying infrastructure that Greg mentioned that can be at heterogeneous compute architecture, providing a common interface for those containers to take advantage of so that you could build on one architecture and then deploy into the field, or deploy scaling up or scaling out with different hardware capabilities, different network, different memory architecture, and be able to do that build once and deploy many and deploy everywhere, but also deploy with an eye to what you have available at different places. The theater of operations will have edge devices that will be small swap and have minimal compute, but maybe disconnected network. The central command will have better compute and better networking. Backend HQ and DAT cloud will have the most. And along the way, you'll have a variety of different hardware architectures supporting that. being able to leverage both a combination of a DevOps environment, leveraging containerization, along with something like one API that gives you that abstraction you need, but with the optimizations built in. And that's one of the key distinctions here. It's not that we figured out a way to abstract the hardware so that you don't have to worry about it anymore. We figured out a way to take all the power of the hardware and optimize it in a way that your application can still get that performance improvement, still take advantage of those native instructions.
Well, and I appreciate you said that, because scalable and adaptive, because if I have a capability that's running, it could be running on the edge, in the field, in a portable data center, or back in the cloud, or back in. And if I lose connectivity, or if I lose an asset, I can still carry out the mission, because things aren't so hard coded. Things can be adaptable, and they can flow throughout the system. That is key. And we're finding more, the work I've been doing with Navy, for example, we're finding that is a requirement. I have to be able to continue mission even if I lose assets, or if I lose connectivity. I go into a DDoS environment, for example. I have to continue mission disconnected or connected. And the complexity of doing that in the systems that we have is extremely high if I don't have some abstractions in there that handle a lot of the stuff for me.
Hey, so Darren, Steve, you guys spend a tremendous amount of time working with our customers, trying to understand their mission requirement, what they're doing. Can you guys give some examples on where we've been helping on this edge to cloud, follow the bit type environment?
Yeah, a lot of people think of Intel as just a silicon provider or hardware provider, but we provide a lot more than that. We only sell silicon, but we have developed solutions and reference architectures around this edge to cloud story. And it's really important that we build that ecosystem around it so that we can actually deploy capabilities. A great example, something we're working on, is a naval tactical grid, where they have to do processing on the edge, in ship, in aircraft, onshore, and these applications they have running have to run across this whole ecosystem. And we can't just do that with hardware. So what we have done there is we've leveraged our silicon features plus security features, and building on top of a container ecosystem, we've come up with techniques and solutions that let us build these really complex applications with several microservices that can actually run connected and disconnected. When I have to run in a DDoS environment, or I have to run completely non-radiating, I can still operate. I can still get everything I need to do. I can still run object detection on those sensors in ship without being connected back to shore. I can also receive trace information from other assets out in the field without receiving the whole trace. I can just receive object data coming back in. And the way we did this was we built an ecosystem of software and hardware together, and then we secured that with Intel's security features that we have, so that I can make sure that when I am receiving data, I'm receiving it from a trusted source, instead of a man-in-the-middle attack, for example, someone that's captured my stream and is sending me bogus information. So we have some really cool reference architectures around this.
Yeah, and another example, we've been working on a variety of projects that are looking at the problem of doing edge analytics, but from more than just doing a single sensor-based approach, but multi-domain sensors. So doing sensor fusion at the edge, data fusion at the edge, and be able to do cross-domain analytics where you can actually, not only do you get data sensors from, but you can sort of track objects across both different views or different scenes, and even be able to across different sensor types. And to be able to do that in an environment that can scale up and scale down. So you could have a mobile sensor platform that can do the edge sensing, analytics, and fusion, and then can also hand off to a distributed set of nodes that can work in concert to be able to track an object or track something across all those different existing sensors as well as multi-domain sensors.
So Steve, give an example. I mean, that's a really hard concept. Give an example of what the multi-scene could do. For example,
so there are a couple of really good examples of this. One is, imagine you're tracking a vehicle and you want to be able to watch the vehicle, but also see what RF emanations are coming off of it and be able to track it across time, across different locations within a given environment. And here's the important part. Eventually, a vehicle or a person or something you're tracking, an object you're surveilling, will move between sensors, and so you'll lose them for a moment. What the sensor fusion and the scene intelligence allows you to do is to be able to connect those two feeds, even though there's blind spots, and be able to track that object of interest across time, across those different environments or fields of view, and be able to do. One of the really cool things is that most people think of that in what's called sensor domain. So imagery analysis, video analysis from one camera to another. But what's really powerful is where you can bring in things like motion sensors, audio sensors, RF sensors, and other, IR sensors, and be able to track that same object across those different domains where you may lose video, but you still have RF, and then you pick up video again and be able to show the full life cycle for a given asset or a given object of interest. And to be able to do this at the edge. I mean, this is really where the power is. A lot of those kind of analytics in the past required data centers of compute capabilities. And now we're able to do that at the pointy edge of the spear. And so that's where the innovations. And so do it with a environment that leverages all the same kind of development stuff you do in the cloud. So it's containers, it's microservices, but at the edge.
So that's really cool, because you just told me I don't need a data center to correlate data between edge nodes. Is that correct. What I just heard? I mean,
that's what you just heard. Think about it this way. Your data center doesn't need to go away, because data center is going to be good for giving you a situational awareness across a large field of view or across large periods of time to give you that analytics that you want about what's really going on or what's happened in the past. But for the real-time intelligence, you want to be able to do this at speed in the field. And the power of computing at the edge is now able to do this with fairly large data sets and with multiple sensors without having to go back to the cloud every time. And that's the power of edge compute. And Darren, the other point that you made earlier, I think I want to hit on here, is about the development times. Oftentimes, depending on the mission, depending on the environment, you have to build completely different infrastructure, completely different software packages based on an edge, a mid-tier, a cloud, based on the different kinds of missions, afloat, ashore, in theater. One of the advantages of this approach is that I can build once and not just deploy everywhere based on a particular mission, but I can use that same architecture and that same software for different missions that all have an analytic requirement. So some places you're going to be able to have heavy-duty compute deployed at the edge, so you can scale up to take full advantage of that. Other missions, you may have one computer if you're lucky, and you can scale down to deal with that as well, but you've built the same application. So it really speeds up the development and deployment times for rapidly deploying new mission capabilities, new services, by being able to build it once for multiple mission use cases.
Okay, yeah, Steve, I think building on top of that, though, that then leaves, I think, a big opportunity to do that deep optimization at those different levels, right? And that's where you need, this partner community to come in and help do that, really understand the mission. If we get that infrastructure right and that composability, portability, then you really nail in on the specific, where is the data, what's it doing, and how do I need to influence that.
Now, because of the flexibility that we need, it also, from my perspective, opens up a huge attack surface. Because it's actually pretty big now, right? Where I can have cyber attacks. So Steve, now we're throwing you a softball. I know it's an easy one. How do I secure all of this? I mean, I've got applications, I've got data, and they're out in theater. So they have to be physically secure. They have to be network secured, applications. It now becomes a very complex security profile or security nightmare, it sounds like to me.
Well, it can be. And when you look at it on if you look at an architectural diagram with all the complexities, complexity is sometimes the worst enemy of security. But I think there's some foundational things that you need to do when you start looking at how do you secure these systems. And it goes really back to the theme of this conversation, which is about following the bit. You want to be able to secure the data throughout its life cycle, wherever it goes. You have to think data centric in the way you secure the applications and the systems. The data is going to flow from the edge to the cloud, back again, mesh and peer-to-peer. So understanding where the data flows and protecting the data no matter where it exists, as opposed to a more legacy approach of trying to protect the system and hope that everything that stays on the system. Those days are gone. We have to be able to protect the data independent of what it's running on. This is why concepts like risk-based approaches over the last several years, and more recently, the approach around zero trust has been gaining traction, because it does take a systems independent view of security. In the case of risk-based, it's understanding the risk of a given function or given asset and protecting it to meet the challenges of that risk. Zero trust is really, and a lot of marketing is going into it right now.
I was going to call BS on zero trust. I'm just saying.
I would be careful about that. I wouldn't call BS on it. I would call BS on the products that say they can do everything for you.
Okay, because it's a marketing fluffy term.
So
zero
is defense in depth, and so is every other architecture we've dealt with. Think about it differently. Don't think about zero trust as a technology. It's not. Don't think about zero trust as a process. It's more than that. It's an approach. And if you think about zero trust as an approach, how do you approach security? Zero trust basically says, let's stop giving away the entire store. At its core, it's basically saying deny first and monitor everything. And if you want to boil zero trust down, those are the two key tenets. No one gets in unless they absolutely need to, and only for the period of time or for the action they need. There's no, once you're in, you're good. It's constant reauthentication and basically default deny. And the other is continuously monitor not just the security, but the policy, so that if you change, your policy changes along with you. And so that's the notion of zero trust. But the reason I bring it up here is when you apply those notions of not authenticating and getting away with murder and monitoring everything, and then you marry that with a risk-based approach of protecting the data throughout its life cycle, what you get to is the ability to protect the data as it flows through, regardless of where it is and who's accessing it at any one time, as being independent threats. You're looking at a risk-based approach of the data through its life cycle. And that is the way that you're going to secure these highly complex environments.
I like what you said about there. I'm giving you access for a period of time, right? You have access to this data or to this application for this period of time. I really like that approach, because now if someone does hack in, right, they can't sit there for a year and a half like we saw with SolarWinds, for example.
And remember, a period of time isn't, and it could be literally for just that one action. And that's what a lot of the examples are, is you're giving access for the action you're doing at this moment. If you want to do a second action, unlike today, where if you single sign on, you're good to go, you have to re-authenticate and you have to reauthorize. And that's the other key thing. It's not just who you are, it's are you allowed to do this at this moment? And so if you get infected between now and 2 minutes of now, your access rights are not going to carry forward. And that's the power of this new approach. But it's all building on existing technologies. We're not reinventing the wheel.
So yeah, bring that up, because I mean, these are all philosophical ideas, blah, 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 blah. I understand that. Practically, how do we make this actually work, especially in this ecosystem where I've got devices all over the place? So what can I do?
So practically what you do is you apply a policy that leverages controls that meet the risk of a given system at a given point in time. And then you do continuous monitoring to update those policies in real time to meet the ever-changing threat world. That's the foundation of this. So what does that mean? That means you use the technical controls that the hardware and software security capabilities provide you. So if you're thinking about from your hardware, encryption, secure boot, digital identity and digital authentication of entities and devices, transport, data at rest, data in use encryption, those features, along with the software ecosystem that implement them, threat detection and monitoring, combine together to a set of controls. The policy says, for this data access, we're going to apply these controls, and we're going to monitor this activity. And when you're done, when you perform that function, all of your rights disappear. That's what zero trust really says, is you got to re-authenticate again to do another action. There's going to be some automation to help make this actually work. But really, you're basically just doing multiple steps in logical form in order to verify that you're allowed to do this function right now. The security controls are the same security controls that have been in the hardware all along,
right?
But they're being applied from a policy-driven based approach as opposed to a system-based approach.
I really like, so the policy systems, we can use what we already used to, right? Like hardware root of trust with TPM modules or SGX storing keys. We encrypt everything everywhere, right? In flight, at rest. I like the idea of that policy and the temporal aspect of it. I think that's a game changer right there.
Absolutely. And
yeah,
I think
it will be, right?
Go ahead.
If you're going to connect all these different disparate things to really make it work, you're going to have that policy in place where it is almost that real time. Do you have access or don't you? Or what can talk to what? But it does bring it back. You just mentioned it, Darren, and we're a hardware company, but the hardware is important, right? These features that are in it matter because that's how you build your entire architecture and stack from the bottom up.
Cool. All right. So we have establishing, that zero trust kind of model, the philosophy behind it. We have hardware to support it. What about the ecosystem? Is the ecosystem ready for this? Well, I mean, how do I start working in this new zero trust world, totally distributed? I've got DevOps running. How do I move forward? What do I do?
Well,
Can I go buy this somewhere, Steve? Tell me I can, right?
Yeah. So again, it's not about buying an end solution. There is no silver bullet. It's about properly architecting and generating the right policies to meet your risk and to meet your threats. And this is what the ecosystem does, working with the government customer, is providing that intelligence of understanding the current threat space and that continuous monitoring and update to be able to evolve with the threat. So that's not a static point in time. Well, we secured this thing now. What about 6 months from now? What about 6 minutes from now? That's where the ecosystem comes to play, by having access to the real-time threat data and being able to adjust or apply the controls to meet the current real-time threat and to continually update that. And that's where the ecosystem shines. It's taking the technologies, taking the software ecosystem and applying those policies and creating those policies and then deploying those at scale to leverage hardware, software, and the processes necessary to secure the bit as it flows, again, from the edge all the way through.
So we've been talking about production environments primarily. What about, how do I develop an application in this ecosystem?
We'll throw that one back at you too, Darren. You're the app guy.
I was hoping you guys would have some ideas, because I can tell you from the software side, anytime a security guy comes and talks to me, I show him the hand. I go, back up. You're slowing me down. You're going to lock down all my ports so I can't get access to what I need access to, blah, blah, blah. That's what I do, right?
So Darren, this is where, whether you want to call it Sec DevOps, DevSecOps, DevOps Sec, all of the above come into play. A lot of the security should be handled at that DevOps level. So the infrastructure you use, if you're using containers, those containers should be pre-populated with the instrumentation to enforce those security controls and policies. So as an app developer, you're going to have access to what you're allowed to have access to based on the environment and based on the threat. If you need to authenticate a user, that authentication will be handled by the infrastructure. That's one of the key ways to sort of automate this, is to build it in. And this, again, it has to be built on. So the other thing is, if you're relying on the developer to do the security for you every single time, you will fail, because every developer would do it slightly differently. You have no way of tracking it. So first and foremost, security's got to be built into the DevOps environments itself.
Okay,
so give the developer the capabilities they need and the constraints upon which they have to develop.
So that sounds to me like I need a security development team that are developing common security best practices and injecting those into core base containers that I'm going to use for all my development. Is that right?
I call it you need to build your security infrastructure libraries. You have to have that foundational pieces for which the developers can build their apps.
So they don't have to worry about basic things, like even basic user authentication, right? They can punt on that. They can say, I'm assuming I've already been authenticated because the container is doing that for me.
Well, bear in mind, the way to do this correctly is not to say the developer's off the hook. It's to give the developer a standard API for how to do it without the developer having to be a crypto expert. So the developer definitely needs to say, I need to use authentication. It's a requirement. But the API that you give them handles the heavy lift of how to do certificate, multi-factor, and everything else you're dealing with. Separate the implementation from the implementation of the control. The controls have to be turned on. Some of it can be done at the infrastructure level, but a lot of it has to be done at the app level. But don't make your app developers have to become crypto and security experts, because that will not be successful.
So that's really interesting. That's very similar to the same approach with managing data across this vast ecosystem too, right? An app developer shouldn't have to worry about where is the data. The data will arrive to the application at the right time. Same with security. So what you're really doing is, from my perspective, this approach gives the app developer the time to focus on the application itself, on what they're doing with the data, right, to get an answer out. So that should mean they don't need to worry about the security infrastructure, because my security team is doing that for me. I don't need to worry about the data per se, because an underlying data management plane is handling the data arriving for me at the right time. So I can focus on the business logic or the AI or data transformations, whatever I'm doing. So that should make it so I can rapidly develop these new capabilities. Right. So is that what we're saying?
That's sort of what we're saying. There's still work that developers going to have to do on both sides.
Well,
to make sure they've got the right data, that they can get the right conditioning or formatting on it, to make sure that they're using the right security for the particular threat environment that they've been told. But a lot of the heavy lift and the complexity should be abstracted in the DevOps architecture, into the containers, into the configurations, especially when you start thinking about the network access and you start talking about some of these sort of network denied network environments. A lot of the infrastructure should be able to handle the comms part. The app developer needs to be able to handle the, what do I do if I lose my connection? I should not just sit there and wait. And that's where the application logic can shine. But to tie it back to the hardware, the key about being able to provide that hardware capabilities all the way up the stack is that app developers should be able to leverage their infrastructure that they're on to do those security controls, to do those processing capabilities, to take full advantage. If they have an FPGA, go for it and use it. And if they have SGX, go for it and use it. But the complexity of that implementation should be abstracted into the infrastructure layer.
Hey, Steve, on that one, do you think as a community, we need to do more to manage, particularly these edge devices, manage and monitor firmware, do firmware updates, all the things you don't necessarily think about? Is that in place today, or does a lot more work need to be done to truly monitor these edge devices in particular?
I think this is an area of growth for the industry, is in edge device and it's more than just mobile device management or IoT management. It's really security management at scale. And you pick on a really good one. The firmware security is a big deal right now. There are capabilities available for doing, secure firmware from a boot perspective, secure firmware management, update, monitoring, secure rollback. Those features exist. There's a standard from NIST 193 that specifies what you should do. And we're seeing the ecosystem provide those building blocks. And now we're starting to see software vendors come in and take advantage of those hardware features to allow companies to manage, monitor, and deploy at scale. Whether it be things like Microsoft building in firmware update into their management updates, so when they go patch, they can patch firmware too. To products and companies like Eclipsium that allow you to do monitoring of firmware at scale within an enterprise, and then managed service providers like Spry Squared and others that will do this for small businesses and for government agencies as well. We're seeing this ecosystem grow, but this is going to be one of the key areas when we look at the slide that Greg showed in the beginning around the follow the bit and that complex in-theater environment, managing those devices and making sure that they're secure in order to be able to support the data security and the profiles and the policies that you want to deploy on those systems is going to require an innovation level use of security capabilities at scale. And that's why the ecosystem is really growing now to meet that challenge.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, Give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.